Hey guys, this is Cooper King Science. Today we're going to be taking a look at this X-ray transformer I got recently. I built a driver's circuit for it, and with it I can get around 60,000 volts, which makes some amazing arcs as well as some incredible corona. First, let's take a look at the circuit that drives this thing. The main source of DC power comes from my Variac feeding into two paralleled power or step-down transformers. The Variac puts out 0 to 130 volts AC at around 4 amps, and the power transformers can put out 0 to 32 volts AC at 15 amps. This AC current is rectified by a large 1600 volt 100 amp bridge rectifier and smoothed by a big 8000 microfarad capacitor. It's rated for 40 volts DC. After all this, with the slight multiplication factor of the bridge rectifier, we get about 35 volts DC at 15 amps, which is a pretty good power source for many projects. Now, the DC from that large power supply has to be pulsed by a square wave running through a transistor, and the circuit that I'm using is a basic 555 timer running in astable mode, and I run it at around 25 kilohertz. It's powered by a small 9-volt battery. Let's take a look at the square wave on an oscilloscope. Looks like the circuit's working. We've got a nice square wave. If I fiddle with the potentiometer in the circuit, I can change the frequency. This way we can find the optimum frequency for running the transformer. The square wave from the 555 circuit is used to switch this IRFP260N transistor. This way we can switch the much larger 35 volt DC current at whatever frequency we want to. The pulsed DC current goes through the primary coils of the X-ray transformer. I have a small resonant capacitor across the primary coil as well. Well, it's time to run the circuit. The first thing we need to do is power up the 555 circuit, and then power up the Variac and turn up the voltage. In this first shot I have a meter stick behind the arc so you can see what kind of gap this thing is jumping. Looks like we're getting about 60 millimeters or 6 centimeters, so that's about 60,000 volts. Let's try connecting the output to the bottom of a normal incandescent light bulb. When high voltage is applied, little tendrils of high voltage try to jump out and escape the glass. It's just trying to reach ground. Now, this may look like an ordinary plasma globe, but I would not recommend touching it. I think it'll give you a little more shock than you're looking for. Well, to finish up, I'm going to try and draw some long vertical arcs, see just how long of an arc I can get. So, sit back, relax, and enjoy the show. Well, I hope you enjoyed watching my transformer do some arcing. I had a lot of fun putting together this circuit, but I think I breathe enough ozone for one day, so I'm going to go ahead and power down. Anyways, thanks for watching. Please subscribe, and I'll see you guys in later videos. Bye.